It's Jeff, CTO and co-founder of a company called Juju Games, and I know we've got lunch coming up, so I'm going to go as quickly as we can. We're going to talk about a little bit of what it's like to actually run Cassandra in production. We've been in production since 0.6. So a lot of these meetups and summits you'll go to, you'll have people talking about Cassandra, and a lot of them have just deployed it. It's been 6 months, it's been one that launch. And they've got some insight. I think we've got some unique insight that we've been running it longer than a lot of people have. So that's what we're going to talk about today. At Juju Games, you've never done this. You can say that really confidently. Even if you've seen what we've done, you didn't know we did. We live behind the scenes, building game technology that other people use. We've worked with almost every publisher in the industry, from Activision to Capcom, Konami, to EA, at various times over the past 15 years. Some of it was little minor, some of it was little major, some of it was using Cassandra. So you don't know about us, but that's what we do. We build gaming technology. One of the fundamental points of gaming is that gaming is about making decisions. The simplest game you can think of, if it's any words or if it's tic-tac-toe, it's about making decisions. And one of the things that's been pretty clear is if you can show how people make decisions, you give them a chance to go back and review those decisions, they'll go and play the game again. And for the clients that make these games, getting them to go back and do that has a lot of value to them and a lot of value to us. So more specifically, we build technology that lets gaming companies show gaming players what they've done in the past. Very simply, we store a lot of gaming data, and we analyze that in ways that helps players enjoy the game. Let them go back and see good games they played, bad games they played, and whatnot. And it turns out that's an awful lot of data. So if we look at a title like Call of Duty, we started working on Call of Duty in 2008. We started some of the initial websites that started showing player stats online, player files online, leaderboards online. The data that comes in for those games is significant. Activision in particular has a data warehousing company that actually collects that data, and they were using MySQL. They've started moving to Cassandra. But just to display that data on the website was using many MySQL servers on the order of 8 to 10, all of those doing about 10,000 queries a second, and they're not really tolerant of downtime. Gamers, Patrick mentioned it earlier, when PSN goes down, people get mad. So when we go down, people get mad. So we started in that space looking for an alternative. So Activision had the data warehouse, other clients didn't. So as we were looking for solutions for people like Bootstrapping Games, and Capcom and Konami, we started investigating Cassandra in 2011, sorry. And that's kind of where I'm going to jump off. The one thing that's worth noting is games different. A lot of you guys may have data models that grow over time, and it gets a little bit of data over 6 months and a little bit of data over a year. My data comes in the first 2 months. And more than that, almost all of it comes in the first week. My biggest user spike is going to be within the first couple of days of launch. So I don't have a lot of chance to learn. I don't have a lot of chance to really show my SQL. I don't have a lot of chance to rebalance databases. So we're looking for something that fit that. We are very risk averse. We don't tolerate downtime. We were going to go jump off a cliff. We have very low latency requirements. And the end result for all what we want to do is basically take as much data as we can, shove it in, show it back as much as we can, as often as we can, for as long as we can. So jumping in, we started evaluating all the different options in 2011. One of the first ones we looked at was Bash's React key value storage. If you haven't looked at React, it's a beautiful database. It is a very clean key value storage. It's all via HTTP. It has MapReduce via JavaScript. It's a beautiful database. If you haven't looked at it, do yourself a favor and look at it. You may not want to buy it. It's fairly expensive. It's about $5,000 a server if you want to do multi-data center. But it's a beautiful database for a lot of use cases. We ended up not using it. We also looked at MongoDB. If you're here, you've probably also looked at MongoDB. MongoDB in 2011 had a lot of very unsafe pieces. It's getting better. Again, if you're here, you probably also skipped it. We investigated Hadoop. If a key value store is sufficient, you could probably do the same thing with lots of small files, with the key being a file name and moving on like that. The dependency on name nodes and single point of values made us very, very nervous. We actually seriously considered it for a very long time. We skipped it because the single point of failure potential. And then we jumped to Cassandra. And Cassandra 0.6 is not the Cassandra you get to know today. If you just started using Cassandra, in 0.6 it was wildly different. For one, well, we'll skip the slides. Our first test, we actually tested it with PHP, and the test immediately failed. In 0.6, the only interface to Cassandra was Lift. Lift's PHP bindings were awful. There was an open bug that took about 6 months to close that made it completely unusable. So a lot of people that actually dove into Cassandra back then failed miserably. And if you look at the landscape of people using Cassandra now, a lot of people aren't using it on PHP because going back to 2010, 2011, it flat didn't work. The one thing it did have going for it was a very active IRC community and a very active Planet Cassandra. A lot of customers, a lot of good development going on. The guys at Twitter were really helpful. The guys at Dig were really helpful. Rest in peace. And there was a lot of good APIs that were coming out. Casa in particular was really, really helpful for us. We took all of the PHP code, we dumped it in Python, and it ended up being a nice, suitable interface. I'm going to skip some drawings, so we don't have time for that. But back then, we were dealing with a Cassandra that was lived over. There was no native protocol. If you used a native protocol with things like native paging, it didn't exist. There were no secondary indexes. There was no CQL. The notion of repair existed, but nobody could get it to work, including us. We launched and we were in production on real data that didn't, couldn't be repaired in the normal way. There were no TTLs, there were no collections. But we were really conservative about it. And I mention this because a lot of you, as you started going and investigating Cassandra, there are things where Cassandra is an awesome fit. There are things where Cassandra is a horrible fit. Don't jump all in and shove everything in Cassandra. It's probably the worst possible decision you can make. We didn't do it. We initially didn't use Cassandra for anything where we couldn't match the data model exactly. Leaderboards are one of the things we do the most. Leaderboard sorted tables in Cassandra sound pretty natural. The native file format is sorted, that's why it's called an SS table, it's a sorted string table. It turns out if you actually try and implement a leaderboard in Cassandra, you can't do most of the basic things. You can't get the first 10 players very easily without making a ton of tombstones. You can't find an arbitrary player in the leaderboard. You can't get the rank of an arbitrary player. It's a horrible fit for leaderboards. We don't try and force it in. We use Redis, and I won't use Redis as a clustering system. I won't use Redis with replication. But Redis and ZSets give us bigger login leaderboards that work very, very well. So pick and choose your battles with Cassandra, and find the data models that work, and it'll eventually be a natural fit. We get a little bit clever with things like leaderboards, in the sense that we store the data in Cassandra for leaderboards. We just don't try to sort it. So we'll take all of the data as it comes in, and we'll put it into Cassandra, and then we'll pull it back out and actually ETL it into Redis for sorting for the actual leaderboard operations. One of the few clever things we do is every cell in Cassandra has a timestamp. Cassandra uses those to determine when to overlay data, so if you hit the same block twice, it'll tombstone one and to keep the next. We actually manually use the timestamp field as the score. So we actually put the player's score in the timestamp so that the highest score always persists, the lowest score is put away. And we don't actually have to do any check and sets. We can always just keep pushing the score into the data, and if there's a higher score already in, the Cassandra goes away for us. It doesn't hit the disk at all, it doesn't Tombstone, there was no leads, there was no latency at all. We shove it in, the mem table might keep it, the mem table might go away. But there's some internal features of Cassandra like that can be leveraged in that way. If you wanted a data model that you only keep the first anything you read, you could similarly have the timestamps the same way and keep the timestamps as the value for the when to keep data. When we went live in 2010, our very first cluster was there was no clients on it, but it was active client dev. So we had clients in Japan that were actively developing against it. So their daytime was our nighttime. So it was tier 1 production for us. It couldn't go down. We started with 5 nodes. We ended up with 5 nodes. It was all on physical hardware. We used RAID 1. Rachel just mentioned that RAID 1 is okay. There's some pluses and minuses to it. A lot of the docs are going to tell you to use RAID 0. You can lose a node. It's not a big deal. If you're conservative, and we are fairly conservative, RAID 1 was fine. Back then, there was a lot of differences. Full loads were read in memory for compaction. So if you had a row with 100,000 elements or 100 million elements, it had to fit in memory to compact. If it didn't happen, it would, I don't know. Repair didn't repair. So if you were reading with a low consistency level, it would potentially go away. If you deleted often and you didn't have a way to get those tombstones around, you could have data come back to life. Manual indexes didn't exist. We had multiple, secondary indexes didn't exist. We used manual indexes. We still, to this day, use manual indexes for everything. We don't have any secondary indexes on anything that's game-facing at all. The performance hit on those kills you. Many of you have probably seen something in the docs that mentions real cache. You almost always want that off. If anyone has a use case where they suggest keeping it on, it's probably not a use case. It works well for small nodes that really infrequently change, and if you've got that use case, you can probably let it off in memcache or something else. Coming in 2.1, if you guys are watching 2.1, that does get replaced with the general real cache. If you're looking forward to using that, don't do it yet. 2.1 is not stable. If you guys are looking to jump into stuff, don't jump to 2.1 yet. We ended up on 0.8 with, in 2011-2012, that was supporting a game called Combat for the PlayStation and Xbox. We've done the fortunate use case that we don't ever have to upgrade clusters. We keep a cluster alive and in the same major version for as long as the client's on it, for as long as the game's alive. When that game dies, we kill the code, and we build a new cluster for the next game. It's really convenient for us. I'm happy we can do that for those of you who can't. Sorry, some of the major upgrades are not pleasant. In 0.8, if you weren't using it back then, counters showed up for the first time. And counters showed up and a lot of people jumped to use them. Does anyone use counters now? No. Wonderfully bad. Very, very bad, very less likely to change, likely to fail. Even in 0.8, repair basically didn't work. We looked at things like then or readings or to avoid ever having to do repair. We allowed repair to basically handle that for us, and we didn't try to do the no tool repair. 2011, 2012, June 2012 was a leap second. There's another one coming up in 2015. If you guys have Cassandra in production, expect to stay up at midnight on June 30th, 2015. There's a pretty good chance something's going to go bad. If not with Cassandra, there's something else you can use, so you're going to be awake anyway. Secondary indexes came in. We didn't use them. We still don't use them. I mentioned that really fast. Apologies for that. By the time 1.0 came around, we actually moved up to Amazon. The first couple Cassandra deployments were all on physical hardware. We went to Amazon and we used EBS. Just like everyone says don't use Red 1, everyone will tell you not to use EBS. It will throw a ton of latency at you, and that was certainly the case. We added a ton of mid latency, a ton of dead latency. We saw a lot of I/O bottlenecks, but we were really conservative. We didn't want full data center power outage to really kill clusters, so we took those hits and adjusted the SLA and got through things just for the safety. It's if you go and talk to the data stacks guys, they'll tell you it's probably not the best thing to do. It adds, you have to add extra nodes to the cluster, but what you get out of it is safety. And that was a trade-off we were willing to make. And I think a lot of people still make that trade-off. I'll probably be the only one today who will admit that. But if you worry about safety over potential ephemeral disks going away because the whole EC2 nature disappears, it's not a bad trade-off to make. In 1.0, they introduced compression. And at the time, we had a policy of never using anything for 2 patches after they would come out. And that was the first one we almost left that policy on. We didn't. We ended up waiting because we had the disk capacity. But when compression came out in 1.0, it was beautiful. These days it's the default. It's still beautiful. The algorithms have changed, but at this point it's almost always a net gain for you. It's going to save disk. It speeds up I/O. It's going to be a net gain. You should probably be using it if you're not. It also does some built-in checksumming for you, since there is no other validation in Cassandra now to detect disk reduction. Compressed tables are the only way to detect disk reduction at this point. So if you turn on compression, you get that as a fun side effect. In Tekken 2013, we went up to 1.2. We stayed on EBS. That was our last EBS cluster. 20 nodes. We're using M1 extra large. Those are not big instances. If you guys are familiar with the M1 class, I think it was 8 gigs. Again, a lot of people, especially with data sections, will tell you you need 30 gigs. And it certainly runs better with 30 gigs. You can get away with very small deployments. And 8 gigs certainly is sufficient. Running on EBS is sufficient. You have posits, you will have GC that gets in the way. Things like that will be slow. The heap is small, so at least GC is fast. But it's totally doable to run it on an M1 extra large. Just like we didn't jump to compression, we didn't jump to CQL, which was good because it changed 3 times. The CQL you guys see now is CQL version 3. CQL 1 and 2 looked very different. So we decided not to jump because we saw it still changing. We didn't jump to vNodes later. vNodes came out 1.2. We tested it, and the test failed. If you guys tried vNodes and you looked at the shuffle stuff, it didn't work. A lot of things that get introduced tend not to work at all right away, and they tend not to work correctly for about 5 patches. So as you look at new features coming out, be skeptical. It's wonderful software, but it's community driven. It takes time to do it correctly, and there's not a lot of people testing these things to begin with. So be skeptical as it comes out. 2014, we actually went to our first productized software. We started in offering software to the general public. Instead of going to the big publishers, we started making it available for small studios. Our new clusters all are based on the I2 class. The I2 class, if it happened within AWS, is awesome. We've used I2 extra larges, which have 30 gigs of memory, and they have 800 gig SSDs. The 800 gig SSDs is almost a perfect spot for Cassandra. It's enough data per node that you can really build quickly. It's enough data space that you don't feel like you're wasting memory in the CPU. It's not so much that you can't rebuild it if a node dies. It's a beautiful sweet spot for Cassandra in particular. The disks are fast enough that we haven't had a bootstrapping streaming failure. A lot of people, when they add or remove nodes, or if they repair it, things will go bad. You'll talk to a lot of people, even guys who know what they're doing, that will tell you that you can't always add a node to the cluster on the load because as things get bad, you want to add nodes. get to a point where the cluster isn't healthy enough to add a node, the I2 instances with the SSD disks make all the difference. We've never had a cluster that couldn't take a node. The bandwidth is there. We finally jumped to vNodes. We jumped to vNodes with 32 tokens per node. The default's 256. If you use the default, you get a lot of nodes. You will see slowdowns. Not everything in Cassandra works with 256 times 50 nodes. That space ends up being a lot more token ranges than a lot of people expect. You don't need 256 tokens per node. The advantage of vNodes is that you add a couple extra physical machines to each token range. 32 tokens per node will accomplish that just fine. You don't need 256. We finally made the jump to CQL3. We do use collections. We use really light secondary indexes. Much like AS time series. I don't want to stop anyone from going to lunch, so I'm just going to take a few more minutes. We use time series. We also use counters. Counters have a lot of known flaws. They overcount. They can be very bad in the case of commit log replay. So if you have a node that had a bunch of counter updates, it goes down, and then commit log replays, you get the same counters twice. We like to exploit the high resolution counters. So if we have per-second timestamps, we don't care about the per-second counters after 60 days. It turns out you can't have TTLs on counters. If you have a use case where you want to exploit out old time series data, consider not using counters. I've talked to the guys that work on the counter code. They have no interest in adding TTLs to counters. I've tried to pitch it to them a couple times and it's not going to happen. So if you happen to use counters, don't plan on using TTLs. So you be prepared to manually exploit data. The one thing we do is we drop GC per seconds. So we drop the time that tombstones live, so that when the counters do expire, when we manually go into the counters, they clear the space really quickly. If we didn't do that, we'd get tombstone overwhelming exceptions pretty quickly. So if you're making a lot of second resolution counters, deleting them, you will end up with a lot of tombstones. So make sure you drop GC per seconds that will compensate. 2.0 had some rules of business. We don't jump until the 5th patch. 2.0 came with an HSHA, the half synchronous, half asynchronous live server. Actually, it introduced corruption. It corrupted SS tables on disks. It could have been really bad. We didn't have a ton of problem with it. I saw a couple of people online that had some problem with it. It's just a really good example of why we shouldn't jump on the very first 0.1, 0.2s. When we updated to get it out of that, there was a couple other annoying bugs. Not bugs, but they introduced some changes. Not really a big deal. As we go forward, we get towards the end of this year and moving into next year, we started using Cassandra to power Titan. Titan's a graph database made by Aurelius. Aurelius happens to be the company that DataStax just acquired. So in terms of people using graph databases and things like that, instead of joins, we tend to use graphs anywhere we used to use joins. Titan blends well on Cassandra. It's a good fit for us, maybe a good fit for you. It's worth looking at. We use that for things like sales recommendations and reviews and tracking when players do certain things. 2015 in 2. Actually it's in 2.0. 2.0 higher than 2.0.11, and in 2.1 Spotify published a date-tier compaction strategy. If you do time series data, it actually groups data on disk based on the time it was written, which gives you a very easy way, as you expire that time series data out, you can expire the whole file and actually wipe out the whole file. If you do use the size tier compaction or you use level compaction, you can end up with old tombstones in the disk or in the SS tables that don't get cleared out very quickly because the old files don't get compacted very often. In 2.0.12 or so, 2.1 point something, we're planning on jumping up and using it. If you do time series, you definitely want to look at data compassion strategy. So just to kind of summarize, so we can go to lunch. We've been using Cassandra 5 years. There's people that have used it longer than us, but there's not that many of them. We still love Cassandra a lot. It's got its flaws, and it's going to have bugs. So the biggest thing I wanted to point out in this talk is be skeptical of the features, especially in features that come out in 0.0 releases. They're often not super well tested. So don't jump to it with bench just because it's new. Patrick mentioned 3.0 is going to come out this spring. I wouldn't touch 3.0 for production until 3.0.4 or 0.5. Other than that, it's beautiful. They've added features very, very quickly. The Cassandra that we started using and started loving looks nothing like what we have now. And it's changed for the better. And it's changed every 6 months for the better. So beautiful software changes out there. Just be skeptical with it. It should be in good shape. Questions before lunch? Sweet lunchtime.
Testing, there we go. Thank you everyone for a great morning. Just so everyone knows, we're going upstairs. The third floor will be serving lunch for the next 45 minutes. So make your way third floor. The area is Catalina. You'll see the folks up there grabbing food. We encourage you to join us. Thanks.